Hello. In video assignment number 2, we have another problem. A company manufactures two items which are sold in two separate markets where it has a monopoly. The quantities Q1 and Q2 demanded by customers and the prices P1 and P2 in dollars of each item are related to the following functions. P1 is equal to 600 minus 0.3 times Q1, and P2 is equal to 500 minus 0.2 Q2. And then it gives us the total cost function, which is C equals 16 plus 1.2 Q1 plus 1.5 Q2 plus 0.2 Q1 times Q2. And it wants us to maximize the total profit of this company, and it gives us guidance in three parts. So first, we're going to write out all of these equations that we have here. So P1 is equal to 600 minus 0.3 Q1. P2 is equal to 500 minus 0.2 Q2. Cost is equal to 16 plus 1.2 Q1 plus 1.5 Q2 plus 0.2 Q1 Q2. Next up, we have to find the amount of revenue that the company makes, because we just have the cost and the prices. So we can define the revenue as the function price 1 times quantity 1 plus price 2 times quantity 2, which gives us the total amount of money that the company makes from the consumers buying the products. So the total profit of the company is thus the revenue minus the cost. So we'll write this out. The revenue is P1Q1 plus P2Q2 minus 16 plus 1.2 Q1 plus 1.5 Q2 plus 0.2 Q1 Q2. Now, as we see here, we have four different variables in this function of P. So we want to really condense this into two variables. And we can do this using these two equations right here, the P1 and P2. So we can make P as a function of Q as well. So we'll go ahead and just copy paste the top function into all of the P's right here. So we have parentheses, 600 minus 0.3 Q1 times Q1 plus 500 parentheses minus 0.2 Q2 times Q2. And then we'll go ahead and distribute that negative. Minus 16 minus 1.2 Q1 minus 1.5 Q2 minus 0.2 Q1 Q2. Okay, now we've got P, a function of Q1 and Q2, equals this whole equation. We'll go ahead and simplify this equation. I will skip a few steps just to take up less time. But in total, this equation equals negative 0.3 Q1 squared minus 0.2 Q2 squared plus 598.8 Q1 plus 498.5 Q2 minus 16 minus 0.22 Q1 Q2. And this is just distributing this Q1 to and this Q2 this way and combining like terms. So now that we've got a function of two variables, we are now told to find the critical points of f in the region R. It is important to note that this region R, it's only the first quadrant of the plane, because the company would not want to sell negative quantities and would not want to make a negative profit. So in order to find the critical points, we will take the derivative of the function. So derivative of P with respect to Q1, we get that to be negative 0.6 Q1 plus 598.8 minus 0.22 Q2. And then P with respect to Q2, that equals negative 0.4 Q2 plus 498.5 minus 0.22 Q1. And we will set these functions both equal to 0 because we want to find the place where the derivative of the function equals 0. And simplifying, let's take the top function first. I'm going to take the bottom function first. And what we're going to do with this function is we're going to solve for Q2. So we have 498.5 minus 0.22 Q1 equals 0.4 Q2. So we just moved the Q over to the other side. And then we're going to divide everything else by 0.4. We're going to get that 1246.25 minus 0.55 Q1 is equal to Q2. And at this point, we have one variable solved for in terms of another variable. So we will take the second function, or the first function, this one, and we will plug this Q2 into this Q2 right here. So we get that negative 0.6 Q1 plus 598.8 minus 0.22 parentheses 1246.25 minus 0.55 Q1 equals 0. Okay, after this we simplify more. We distribute the 0.22. We can now combine like terms. And then 324.625 is equal to 0.479 Q1, leading us that Q1 is equal to 677.7139875. Okay, so now that we have one of these variables, we can solve for the second variable. So we'll use the second equation for Q2 negative plus 498.5 minus 0.22, and then we will plug in the Q1, 677.7139875. After this, we get that 0.4 Q2 is equal to 498.5 minus 149.097072. And skipping the addition step, we get that Q2 is equal to 873.5073069. So by solving the two derivative functions and plugging in the values, or solving the system of equations, we get that there is only one critical point at 677.7, 873.5.